There are many massively multiplayer online role-playing games out there, also known as MMORPGs. My favorite just so happens to be Old School Runescape. In Old School Runescape, you can do fun things like walk around, chop wood from trees, mine valuable ores from rocks, fight many different challenging monsters, collect cool loot. Wow, I got some bones. Let's bury those for my prayer skill. And many more things through Old School RuneScape's 23 skills and unrivaled challenging leveling system. This video and accompanying assignment will simulate parts of this wonderful MMORPG. Specifically, moving around the map, chopping wood from trees, mining ore from rocks, and placing your loot in the bank. For this assignment, you have already been provided with a main.cpp file which you will write your code inside of. The first thing that you want to do is fill your map with all of the entities that it is comprised of. Let's take a look at what an entity looks like. An entity is a data type made out of a struct that contains one double, which is a chance, which we will get to later, and a string, which is the type that the entity is. You are also provided with a CSV file that looks just like this, that for each record within the file contains an X coordinate, a Y coordinate, and a type for the entity the record represents. You will need to read these separate entities as records into main.cpp in this read map function, which has already been provided for you as a prototype and function stub to read these different records into the map of entities. So when you read a record in from over here inside of this read map function, it will look something like this. You will need to break up the X, Y, and type on the commas right here and right here by first finding a comma and then taking a substring up to that comma and then finding the next comma, taking a substring up to that comma, and so on and so forth. If you need any help with this, you can find a video linked in the cards right above to see how to do that method. Once you have separated out the X and Y coordinates and the type into separate variables, you can then place the entity from the record into the map by using the Y value that you get as your column and the X value that you get as your row, and saving the type at that location within the map. You will also want to set the chance field of the entity if you have either a tree that you read in or a rock that you read in. In the case of a tree, you will want to set the chance to 80%, but don't set it to 80, set it to 0.8 because percentages are between 0 and 1. And in the chance of a rock, you will want to set the chance to 40%, but again, do not set it to 40, set it to 0.4 because chances are between 0 and 1. You will want to read every single record from this file and place the appropriate entity at the XY coordinate that it wants inside of your map for all of the records within this file. Once all the records have been read into the map, you can then end this function. And when you come back to main over here, after read map has been called, when you call display map right here, it will display all of the different entities you read in within the map. And you do not need to fill out this display map function because it has already been provided and filled out for you. But feel free to look through it to understand how it works. So when you compile and run this program, you should get a map printed out that looks just like this after you have completed your read map function. And right after that, it will ask for a command, because if we look at main, it will display the map using the provided display map function. It will then try to display the inventory, but if we look at the display inventory function, we can see that it doesn't do anything when there's nothing in the inventory, and it will also try to display the bank, but again, if we look at the display bank function, we will see that that function also does nothing when there's nothing in the bank. So these two functions print nothing. This command doesn't get printed because it is initially nothing. And then we call the provided get command function, which again is something you don't need to write. because it's provided for you. And in that function, it asks for a command, reads that command in as a string, lowercases all of the characters within the command, and then verifies that it's a valid command and only returns that lowercase command if it is a valid command. So since all of our game mechanics are currently doing nothing, if I enter a command over here, it will just output the command that got entered and then ask for a new command, because again, the mechanics are doing nothing right now. So it just loops back around, displays the map, and again, there's nothing in the inventory and bank, but now since the command has something in it, it just outputs that command. Now let's add some functionality, also known as mechanics, to our game. And the first mechanic that we want to add is the move mechanic. In RuneScape, you can move by simply clicking around on the map where you would like to move. You can also move by clicking around on the minimap, but we don't have a mouse to work with, so we will just take typed in commands from over here on our terminal. For the move functionality, you will want to add a prototype for the function up here at the top of your program, the prototype being right here in the assignment PDF. So the function will return a string, it will be called move, we'll take a player as reference, and a two-dimensional array of entities, aka your map, as the parameters. This is the first time the player is being used, so let's go take a look at that data type. So here we have the player data type. First, within the player data type, we have this inventory size, which is an integer. And that simply is keeping track of how many items are in this inventory, which we will be adding items to later on. We also have a one-dimensional array with two elements inside of it, those elements being the XY position of the player. When the player first starts playing, they will be at X coordinate 14 and Y coordinate 7, which is column 14 and row 7. There is also a one-dimensional array that is for the inventory that will be holding entities, and this inventory has a size of max inventory, which you can see up here, is a global constant set to 24. We will add items to this inventory later. So you will want to add this prototype to the top of your program, a stub or definition to the bottom of your program, and a call to the function within main to add the mechanic to the game. This call to the function should save whatever is returned back from the function so that it can be output up here, so maybe save it into the command variable. When move is entered, it should call the function that is called right here. Inside of the function, you will ask for an X coordinate, which is just an integer. So you will need to loop to get a valid integer from the user, and a valid integer is one that doesn't have input failure. It's one that isn't a negative number, so the smallest value it can be is 0, and it's one that is not bigger than the end of the x's, which you can see 29 is the end of the x's, which is kept track of in the program in this map x size global constant. So you can just verify that the value is less than that global constant. So if input failure is entered, an error should be output. If a negative number is entered, an error should be output. If a number 30 or larger is entered, an error should be output. But once a positive number less than 30 is entered, it should go on to asking for a Y coordinate, which is just another integer. So you'll be looping again, getting another integer, which will have the same 3 errors you'll be checking for, except for the maximum point being the map Y size. So if you enter in failure, again, it will give you an error. A negative number will give you an error. So once you enter in a positive number that is less than the maximum Y coordinate, you can see the player will move through the map. And the player will move through the map because you will just update the position to being those new XY coordinates that were entered. And when this loop loops back around, it will display the map. And when it displays the player, it will display that player at its new position within the map. There are some errors you need to look out for though, because you cannot move where there are already objects in the map, such as trees, rocks, walls, or bankers. So if you go to, say, a tree's position, such as 0, 0, you should output just to the terminal that there's a tree in the way. You just do that by outputting the type of what is at that location. Or maybe if we go to this location, which would be 29, 0, you see it says a rock is in the way because now I'm just outputting the type of what is in that location. Or maybe if I go to, 9, 10, it will say that there's a wall in the way. Or if we go to space 1113, you see it says there's a banker in the way. So we just check that location that gets entered. And if the type is not blank, we can just output that there's a whatever type in your way, and then ask for a new XY coordinate. But once, say, a valid XY coordinate, such as that spot right there, which is 0, 10 is entered, you see you should return from the function the string moved to position 0, 10, so that when the loop loops back around, it can output that message from right here. So now that we can move around, let's add functionality to be able to chop wood from trees. The prototype for the chop function looks just like this, and you'll notice it takes in a player via reference and a 2D array of entities, which is your map. When you add items to the inventory of the player inside of this chop function, it will add those items to the inventory of the player inside of main because the player is being passed via reference. The first thing you'll notice is to be able to chop wood from trees, you have to be directly next to the tree that you want to chop. The player in our game will not start next to a tree. They start at position 14, 7. So if the chop command is used initially, it should just return the no wood nearby to chop error message, which will be returned from the function right here. And when this loop loops back around, it will be output right there. To determine if there is any wood nearby to chop, you will take the player's position and you will look at the Y-1 spot, the Y+1 spot, the X-1 spot, and the X+1 spot, or an entity that has a type of tree. And if you find one, then you know there is a tree nearby in one of those 4 locations. But if you don't find one in one of those 4 locations, then you just return that there's no wood nearby to chop. If the player is in a position next to a tree, just like this position 6-6 that I've moved to, then when the chop command is entered, if the inventory is not full, which I will go over in a second, you will either successfully chop the wood or unsuccessfully chop the wood, which I will go over after I've gone over the inventory. And again, to tell if you are next to a tree, you'll just look at the Y-1, Y+1, X-1, X+1 spots. And if in any of those spots you see a tree as a type, then you are able to chop the tree. So I saw a tree in the Y-1 spot, so I'm able to chop a tree from that spot. But let's talk about one more error we can get before we talk about successfully or unsuccessfully chopping wood. And that error happens when you have a full inventory. And when you have a full inventory, you're going to want to return from your chop function this inventory too full to chop wood error message, so that when the function finishes executing, that error message can be displayed right here. You will know the inventory is full because you have this global constant called max inventory, which has a size of 24. And when your inventory size hits that size of 24, you can no longer add things to your inventory. So again, you'll just return that inventory too full to chop wood error message, which will be output when the loop loops back around and outputs it right here. But if you are next to a tree and your inventory is not full, when the chop command is put in, you will either successfully chop the wood or you may unsuccessfully chop the wood. To determine if you successfully or unsuccessfully chop the wood, you will first want to call this RNG function. This RNG function will give you back a random number every time it is called, but it is deterministic, so it will give you back pseudo-random numbers, meaning every single time you run your program, you will get the same random numbers back in the same order. That random number will be between 0 and 1, so you can call this function, get back a random number, compare that random number to the chance of the entity that you are trying to chop wood from. If the random number is above this chance, then you will say they are unsuccessful at chopping wood by returning it from the function. But if the number is less than or equal to this chance, then you will say that they are successful at chopping wood. And if they are successful at chopping wood, you will add an entity to the inventory. That entity will have a type of wood. You will add it to the inventory size position of the inventory. After that, you will increment your inventory size by 1, and then you can return the successfully chopped wood message from the function. So when the function returns and this loop loops back around, it can output that success message right here. Now let's add mining rocks to our game. The prototype for mine is very similar to the prototype for chop, except for the name of the function is different. It takes a player via reference, so whenever you add items to the inventory of that player, it will reflect those in the caller, aka main, and it also takes a two-dimensional array of entities, which is your map. And most of the explanation for mining rocks will be the same as chopping trees, so rather than re-explain everything, if you need the explanation again, go back and see the explanation for chopping trees, and just replace that explanation with the error messages for mining rocks. So just like with trees, you needed to be next to the tree, well, with mining rocks, you need to be next to the rock that you want to mine in order to mine the rock. So when the player is not around any rocks and the mine command is entered, your function should return this no rocks nearby to mine error message, which will be displayed right here from main when the loop loops back around. If the player is next to some rocks though, when the mine command is entered, they will either successfully mine the rocks or unsuccessfully mine the rocks. So the successfully mined rocks message should just be the successfully mined rocks message, and the unsuccessful one should be this unsuccessful at mining rocks message. And to determine if it was successful or not, it is the same as when we were chopping trees. So grab a number from RNG, compare it to the chance of rocks. If that random number is over the chance, then you are unsuccessful at mining rocks. But if the random number is under the chance, then you are successful at mining rocks. So you'll want to add a rock to your inventory and increase your inventory size by 1 and return this success message. Otherwise, you'll just return that unsuccessful at mining rocks error message. And those messages will be output when the loop loops back around and outputs them right here. And lastly, for mining, the inventory may be too full. It will take a lot more mining in order for your inventory to be full, because the probability for mining rocks is half of the probability for chopping trees at 40% versus 80%. So it will take longer to get a full inventory of rocks. But once you have a full inventory of rocks, you should return that the inventory is too full to mine rocks whenever they try to mine the rocks. Lastly, let's talk about banking items, because when your inventory becomes full of items, such as my inventory over here, you will need a place to be able to store those items so that you can place more items in your inventory. The prototype for the bank function looks like this. It will take a player via reference, so anytime you remove stuff from the inventory inside of here, it will reflect in the caller. It takes a one-dimensional array of entities, which will be your bank, also called your storage inside of the program, a two-dimensional array of entities, which will be your map inside of the program, and an integer via reference, which will be your bank size from within the program. But one constraint our bank will definitely have is that it will not be as large or robust as a normal video game's inventory, because that would take a lot of mechanics to implement. So when the player's inventory is full, or at any point that the player has stuff inside of their inventory, they should be able to go to one of these bankers, deposit the stuff within their inventory. Just like mining and chopping, you have to be next to the bank in order to use it. So if the bank command is used and your player is not next to a bank above, below, to the left, or to the right of you, then this error message, there doesn't seem to be any bankers around, should be returned from the function so that when the loop loops back around, it can be output right here. But if the player is next to a banker either above, below, to the left, or to the right of the player, when the bank command is entered, items should be transferred from the inventory into the bank. So if we look at the player, you'll see that it will go from this one-dimensional array of entities that is the inventory into this one-dimensional array that is the storage, aka the bank. And you'll want to add those items from the inventory into the bank, starting at the back of your inventory, working towards the front of your inventory, because this way you'll just be removing from the back of your inventory, placing stuff in there. And if you don't place everything into the bank because your inventory becomes full, then when you start mining or chopping later on, it will add those items to the end of your inventory rather than having any gaps or anything inside of the inventory. So just remove the items starting at the back of the inventory, working towards the front, and you'll essentially just say your bank, aka your storage array, is equivalent to some item in your inventory array, and then you can decrease that inventory size in the player by 1 and increment this bank size variable by 1. And this bank size variable will be passed to your bank function via reference. So when it is updated inside that function, it will get updated outside here in main. You will also want to keep track of how many items that you are banking. So you'll just make a counter, and each time you successfully place something in the bank, you'll increment that counter, and you will just return banked, concatenated with the counter, concatenated with items from the function to be output right here when the loop loops back around. But if in the time that you are adding items to the bank, it gets full, you will want to append this dash bank full to the end of your message. That is going to be output right here when the loop loops back around. And that is how we will create a basic simulation of my favorite game, Old School RuneScape in C++ in this assignment. Thank you so much for watching this video, and see you in the next one.